Well, let's talk a bit more about differentiating this exponential function. We saw how to differentiate y equals e to the power of x, very basic one. But what if it's e to some other function? Well, I can do this by some sort of substitution. I just say u is some function of x. I'll rewrite my function then as y equals e to the power of u. Remember, I want to find dy dx. Well, I can't differentiate that with respect to x, but I can differentiate it with respect to u, because we now know how to differentiate e to the power of u with respect to u. But to balance it out, I'll multiply by du dx. So I now know the derivative of e to the power of u with respect to u would be e to the power of u, the world's easiest derivative. It is the same as its actual function. Times du dx, well, that's just f dash x, because u was function x. So differentiate u with respect to x, I must get f dash x. And we come up with our formula for doing any exponential where the base is that beautiful number e. We just differentiate the power and put that out the front. The one thing we have to be careful is we don't change the power. Unlike polynomials where we take one off, this one the power stays the same. Okay, so if y equals e to the power of function x, the derivative will be the derivative times e to the function x. And that's great if it's base e. But what if it's some other base? We'll pretty much do it exactly the same way with one added feature. I will also multiply it by the log of a, because what you're basically doing is applying the change of base rule. And so you would end up getting the same thing but times the log of that base. Some examples. Let's start with the world's easiest question. If you ever get this one, you just say, well, thanks very much, nothing to do. Y equals e to the x. Well, the derivative is e to the x. But if it's y equals e to the 5x, we differentiate that power, but we don't change the power. So it's 5e to the 5x. Y equals e to the 4x plus 3, differentiate the power, 4e to the 4x plus 3. Doesn't have to be a linear function. Power is quadratic, differentiate the quadratic. 2x plus 3, e to the x squared plus 3x plus 2. Why did we start looking at calculus? Well, we wanted to find the equation of tangents and things like that. Let's find the equation of the tangent to this curve. Y equals e to the power of 2x plus 1. At the point where the x value is 1, I've got the exact value for y there. So e squared plus 1 is the y value. Y is e to the 2x plus 1. Find the derivative. That allows us to find the slope of the tangent. We want at the point where x is 1, the slope is 2e squared. Point slope formula, y minus y, well, in this case it's e squared plus 1, equals the slope 2e squared, x minus 1. Expand it out, I put it in general form, but there it is. And that is a straight line. Some people look at it and see those squares and think, oh, I haven't got a straight line anymore. Remember, e is just a constant number, and so is e squared. The pronumerals in this one are x and y. It's still a linear function. Y equals 4 to the power of x squared. Oh, the base is not e. That's okay. I do it exactly the same way, but remembering to also multiply by the log of 4. The question then comes, where do we write the log of 4? I tend to put it in the middle, but the one thing I make sure I do is I'll put parentheses around the log 4 to avoid any confusion at all. See, if I didn't put those there, it could be mistakenly taken as log of 44 to the power of x squared. Or if I was to put log 4 at the front and not use parentheses, I could look at it and think, oh, am I saying the log of 42x? So you really need those grouping symbols there. I suppose you could put the log of 4 at the end of it. 2x, 4 to the power of x squared, log 4. I suppose that one's clear. I just tend to do it that way. Whichever. But make sure there's no ambiguity in your answer, I guess is what I'm saying. Well, let's now talk about the natural logarithm. What is the natural logarithm? Well, it's the logarithm that's base e. So the inverse function to the e to the power of x. That's what we call the natural logarithm. So y equals e to the power of x. That therefore means x is the log of y base e, the natural base. Other ways of writing that. ln. Why ln when it's natural logarithm? Interesting. Shouldn't it be nl? No, because it comes from the French. And the French speak funny. Yeah, logarithm naturel. They tend to say it the other way around. So ln of y. The other way, of course, is just to simply write log y. If we don't see a base on the logarithm, we just assume they're talking about the natural log. Once upon a time, we would assume they were base 10 logs. That was back when we used to use the log tables over there, because base 10 was very commonly used. Not so much anymore now that we have the calculators, and so it's now become common practice that when we don't see a base, we assume it's the natural base, base e. If I have to simplify 1 over e, then I can play around with my log laws, and I get, well, that's log e to the minus 1, but that minus 1 can come out the front. Well, the natural log of e must be equal to 1 because it's to the base e. They cancel each other out, so minus 1's our answer. E to the power of 2 log 3. Well, I can also cancel e to the power of log, but not 2 log. Need to get the 2 inside the log. So it becomes e to the log of 3 squared. E to the log now cancels. 3 squared is 9. Now I think we've got enough to do for the next few days.